So you will need to write smaller as we take these notes. I'm going to try to have lines up here so that I can stay straight. Again, remember we do not have the extra time for talking. Alright. Get it to where right there. Alright, so and we're talking about genetics and heredity. We're going to start off by first listing what heredity is. You should be able to fit all of these notes right on the front. I'm writing bigger so that you can see, but make sure that you're writing smaller. What is heredity? In your own words, what's heredity? Raji.
Something that's passed down.
Passed down from who? What's the something?
Traits.
Yep. The traits pass down to who?
You.
Who you? Children. Children or offspring. Good. From who?
Parents.
Parents. So when you got your hair is brown, we say that you what from your parents? You what that from your parents? Inherited that from your parents. I wish I inherited lots of money from my parents, but I didn't. So I'm just sad now. Give me some examples.
Hair color.
Hair color, good. What else?
Eye color.
Good. Hair, I'm just going to put hair and eye color. What else do you inherit?
Height.
Height, okay. You can put that. What else?
Personality.
Personality you inherit.
Health.
Health.
Size. Sometimes.
We're going to back up from health. Yeah, because yes, there are some genetic diseases. Yes, I was thinking of something else. But yes, you do inherit all of those things. So I'm going to put, because sometimes people don't realize these types of things that are not physical to see all the time. Your personality, even that includes your mannerisms, and even some health things like Chappie told us. Who said what? Oh, that's sorry.
Miss Williams?
Yes.
I really feel like your personality-wise, that's like who you hang around.
It comes from that kind of. Like your environment will dictate how you behave and act as well as your nature will dictate, or your nurture, I should say, will dictate. Some things you react a certain way to certain things because of who you are. And that who you are came from your parents. But then sometimes when you hang around people, and then sometimes you act like others, and you'll hear sometimes people say, that's not who you are, that's not how you really act. Because some people will put on a front or try to be something that they're not because of their environment. Or sometimes the environment will kind of dictate how you behave and how you act. But it's a mixture of two. And when I say personality, I also mean mannerisms. Like certain faces you might make, like oh, you look just like your mother when you make that face. And you don't even realize it. And I even know, like in raising my children, I'll say something, I'm like, I think I sound like my mother. And I'm like, I didn't really mean to do that. But it happens. All right, so heredity traits are passed down, and you should be caught up with me because I'm writing right with you as well, so you shouldn't be that far behind me. Or carried in our what? In our genes. And not the genes, put it right on that table, but the genes that are within our what? DNA. Good. Any questions? Oh, I thought your hand was up, Hernandez. So then, let's talk about those genes just for a second. Hernandez, do me one quick favor and pass out some colored pencils to every table so that they want to do their notes. And Brandon told me that genes are located where or make up your what? Say it loud, Brandon.
DNA.
They make up our DNA. Which stands for what again?
Nucleic acid.
Okay, raise your hand. What type of building block is that? Raise your hand.
That is a carbohydrate.
It is not.
A lipid. A
nucleic acid. That's deoxyribonucleic.
I knew it.
All right, nucleotide. It is. Okay. Any questions about this? All right. So genes make up our DNA. DNA are strands of what? Nucleotides, but they're wrapped tightly. Those double helixes are wrapped tightly to give us our what? Chromosomes. So we want to put where our chromosomes are located. And just as a review, we get our chromosomes from who? Again? From your parents. What do you get from your mom?
23.
23. What do you get from your dad? 23, totaling a number of 46 chromosomes. We don't need to write that because we already wrote that, and that's review. But we are going to now move on. Because what happens is you get certain chromosomes from your mom and certain amount from your dad, 23 and 23. And remember, your eye color, your hair color, all of that stuff is a combination of your two parents. So what happens is your parent is going to give you one chromosome of a certain eye color. Your other parent's going to give you the other chromosome for eye color. They're going to link together, and that's going to give you what we call a genotype. And that genotype is going to have either a dominant and a recessive, or a recessive and a recessive, or a dominant and a dominant, and that's going to determine who you are. We're going to write that down in just a second, but are there any questions about what we've talked about here so far? Okay, yes.
I just want to make sure, am I using too many lines already?
No, I just,
And if we need a separate sheet of paper, we'll just add on to it after. All right, so here we have what's called a genotype. Genotype has the word genes because you get them from your parent. A genotype looks like just letters. So for instance, you may have an RR, you may have an R lowercase r, or you may have a lowercase r. So those are just the letters or the genes. So far so good?
yeah.
Okay. A phenotype. Actually, you don't have to put it underneath. I'm going to put it right there.
Beside it, right?
Beside it, so we have space.
Thank you.
Mm-hmm. A phenotype is actually going to be the physical characteristic. So, for instance, when the little
Peas.
Drinka on here
Hey.
was wrinkled and round.
Why I gotta be
Wrinkled and round. That's the physical characteristic. Pheno, physical.
Okay, Miss Megan.
All right? So if I say, what's your genotype, you're going to give me the letters. If I say, what's your phenotype, you're going to tell me exactly what it is. So for instance, if I say that this genotype, capital R, and we'll talk about how to say that in a moment, is wrinkled, not round, and I tell you that this P came out, capital R, what's its phenotype? What are you going to say?
Wrinkled, not round.
Wrinkled, not round. Any questions?
Capital R.
Okay? So right here, we're going to go ahead and draw, let me say this, let me back up for a second. What happens is, yes, questions? Okay. So what happens is, remember I told you you get one from your parent and you get another one from the other parent. But the parents, they bring everything they have to the table. And then there's a possibility of what the offspring can look like based on what the parents brought to the table. The way that we figure out the probability of what the offspring looks like is by using this box type thing. Who remembers or knows what that's called, Raji? A Punnett square. Yes, and I believe y'all did that in Mr. Megan's class. Okay, so here we have the Punnett square. And the Punnett square is basically 4 boxes. And what we do is we take the genotype of the parent, of the dad, and the genotype of the mom, and sit around this box, and we figure out the possibility of each. So we can put the mom up here and the dad down here, or vice versa. It really doesn't matter. We just do parent 1 and parent 2. But this is a Punnett square. And so, again, we take a genotype of the mom and a genotype of the dad. What do we want the mom to be out of these 3 genotypes? What R? There's like a lot of R's up here. Uppercase R and uppercase R, okay. So, we'll do this. Alright. And then, what do we want the mom to be? She could be the same, but for our purpose of notes, let's make her, the dad, I'm sorry. Let's make her one of these. What do we want?
Uppercase R and lowercase r.
So we place hers like that. Now, before we complete this Punnett square, we do want to write down a couple of things or make notice of a couple of things. Who was the scientist?
His name was
His name was Mendel.
Mendel.
I thought it was Andy.
No, it's Mendel.
Mendel.
All right. So Mendel came up with these terms for these letters. These terms for these letters, you have the capital R, and we're going to write it right to the side. And then you have the lowercase r. Who remembered from the video what the capital R was? Dominant. And the lowercase r?
Recessive.
Recessive. And we're going to call these Mendel's terms. And now we no longer say capital R, or uppercase R, uppercase R. We now say dominant, 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 recessive.
So you don't have to say the letter.
We do, but right now these are the only letters here. But if I have a couple, we would say dominant R, recessive R. All right? Any questions for this? No? All right, in addition to this, I'm just going to kind of go around it like this, just so that I know I'm talking about this. Who remembers from the video what these were called?
What word?
What these letters were called? No? When we put them together, that's your phenotype, or your genotype. But who remembers what these actual letters were called? Alleles.
That's a part of crossing over.
Alleles.
Like during the test, they say they use that when they're crossing over.
Yeah. Yes. Because remember with crossing over, good connection, Jenny. Remember with crossing over, you actually take traits of the same size, of the same type, and in the same area. These are traits. Are they not? And they kind of cross over. That's how we get that genetic what? Crossing over gives us genetic what? Variation. Very good. All right, so these are called alleles. So we're good with that?
Yes.
All right. Now, I want to write more down here. So I'm going to, I wish I had more space that I can just zoom up because I do want to write some stuff. I'll write it right here. What is the relationship? Talk to your partner for a second and talk about the relationship between the dominant and recessive when it comes to figuring out a trait. Remember what you remember from the video. I'll say it again. Talk to your partner about the relationship between the dominant and recessive when it comes to figuring out the trait. Go.
About the trait. Yeah. The dominant is always over.
Okay, stop. All right. Jaleel. Oh, you weren't in here. You see the video.
Me.
Brianna.
Oh.
Fill in this blank for the relationship. I want you to write this down too. Fill in these blanks for the relationship between the two. Tell me though, Brianna.
Oh, I mean, I didn't do that. I just thought.
I know, but now with what you talked over, you should be able to fill in this blank.
Oh.
Dominant is always over recessive. What does that mean? Talk to your partner really quickly for 30 seconds and talk about what that means. All right, stop. Tell me what that means, Kylie.
Meaning, like, that's why it's called dominant. So, crazy example.
Mm-hmm.
So, black hair or brown hair and blonde hair. So, black hair and brown hair is dominant while blonde hair is recessive. So, if the child has black hair, then you know that brown hair is dominant.
Okay, anyone else have a way of explaining it?
No.
Raji?
If there's an uppercase R in of the squares, it's automatically dominant.
If there's an uppercase R in any of the square, then it's all in any of the squares?
Yeah.
Okay. Don't just because the way I asked you, don't be
Oh.
unsure of your answer. Don't worry about it. All right. So we have a dominant recessive. What I don't want you to confuse that with, because what society has sometimes confused this with, is because someone has a dominant trait that makes the person dominant. That is not necessarily true. I mean, not necessarily. That is not true at all, unless you're me. And then I'm just joking. No, that's not true at all. So don't confuse dominant meaning that you're better because you have the dominant trait. That's not what that means. That just means that's the trait that's going to show up, or at least push itself through a little bit more. All right, so now let's complete this Punnett square. This Punnett square is none other than just math, how you do when you connect your coordinate points. So therefore, this first box would be what?
Dominant R,
Dominant R, dominant R. Thank you so much, Jenny.
Thanks, Jenny.
The second box going over here to the right would be what?
Dominant R. Wait, are these just that's the mom trace?
So what we did was we took this one and this one, we brought them together.
Yeah, the mom trace on the top.
It doesn't really matter.
Oh.
And we took this trait and we brought them together. Does everyone see how we got that?
Yes.
Okay. Moving down to this box, what do we do?
Recessive R and dominant R.
What should be written first?
Recessive.
The dominant.
Oh.
Even though it's here first, the dominant always gets written first. Okay? So it's going to be dominant R, recessive R.
Dominant R, recessive.
Dominant R, recessive R. So this, remember the Punnett square gives us the what?
The probability.
The probability of the offspring.
Yeah.
So it says, with this particular pregnancy or with this particular fertilization, here are your possibilities. Your possibilities are, let's say if the dominant R was wrinkled and not round, or the dominant R was wrinkled and not round, and the lowercase r, the recessive R, was wrinkled and round.
50-50.
Oh, we wouldn't even, actually, let me back that up. This would be 2. So let's say the dominant is wrinkled and the recessive is not wrinkled. What would the possibility of the child being not wrinkled?
50%.
50-50.
No, 0.
None.
Oh.
Remember, the dominant is wrinkled, the recessive is not wrinkled. All of these children would carry a dominant trait.
Yeah.
So none of them would be wrinkled.
Poor baby.
Now, these 2 children would be carriers of the wrinkle, which means their offspring would have a possibility, but none of their children would ever come out wrinkled.
Oh.
All right? Got that so far? Okay, what I want you to do right now is just talk over with your partners what you learned so far so I can erase this and move on to the next portion. I should hear more talking.
Hopefully the phenotype is biblical according to the genotype and heredity combination albums.
Allows.
Your turn.
All right, stop. Right underneath where we wrote dominant is trait always goes over recessive trait, we're going to write something else. So I'm going to start over here for right now. Let's say our Punnett square is here. Those words are here. Right underneath where we wrote the dominant and recessive, that's where I'm going to start here. So we have another term right underneath where we wrote dominant is always over recessive. And I'm going to write this out first and then we'll talk about it. Is anyone confused about where we write this?
I have a
Okay.
question.
Yes.
Allows.
I'll give you a moment to write that and then we'll talk about it. All right, what's the root word that we know for same and different?
Homo and hetero.
Homo and hetero. So where does homo or hetero go? What goes here? Hetero. Okay? So we do know that thus far.
Yeah.
Okay? And same,
Homo.
homo. Thank you.
How are we being challenged?
Now the term hetero goes for different. The term homo goes for same. So the term that we're looking at when the alleles are different meaning you have a dominant and you have a recessive together, this would be heterozygous.
Ooh, alright.
When it's same, homo for same, that means you have two dominant alleles or two recessive alleles. The letters are always going to be the same. You have ours when you only have two. But whether it's dominant or whether it's dominant recessive, this will be called what, everybody? Homozygous. Not homogeneous, like we looked at before. This is homozygous. Any questions? Remember, homogeneous are like chromosomes. These are homozygous, like genotypes. Really quickly, but I'm moving on. Any questions, other questions about this? All right, then right on the side next to here, which is right underneath your Punnett square, trying to maximize our space here, we're going to talk about how it's possible that there's a blending or a mixture of some traits when two parents come together. So, let's say for instance, we have a rose or a flower, and I'll just, let me see, how can I draw it? Yeah. And I'm coloring it all in.
What is that?
It's a rose.
Flower. I'm not going to do a rose because it's, I'm sorry, I'm going to draw a rose then. So somebody said I can't.
Oh, God.
There's my rose. All right. The reason why I'm coloring this rose in is because it is. We're going to say that the dominant for the rows is red. All right? So this is fully dominant, all the way dominant. What's its genotype? We're going to say that these are, we're going to use R for dominant red, and we're going to use recessive R for white.
Wait.
We're going to use dominant R for red,
Okay.
and we're going to use recessive R for white. Okay? Because what we do is we use the actual letter for the dominant, and then the recessive one just takes a lowercase letter. All right. So if I said that this rose is all the way red, what could be the possibilities of the genotype?
Double R.
What kind of double R?
Dominant R. Double dominant R.
Double dominant R or?
Little dominant R.
No such thing as little dominant R. Dominant R, recessive R. It could be, right?
That's what I
Because it's all the way red. But I'm going to tell you that this one is dominant R, dominant R.
Wait, how could it be recessive R? Oh,
Because the dominant trait shows. Now, this rose seeds, mix, or germinates with another rose. It's all the way red. What's its possible genotype?
Double R or double
Dominant R or
dominant recessive R.
dominant recessive R. I'm going to tell you that this one is going to be dominant recessive.
Wow.
Based on our Punnett square, we know that the possibilities are what?
Endless.
No, they're not endless. What are the possibilities when we breed these two?
Double dominant R.
Look at your paper. Double dominant R or dominant or dominant recessive. Now, in the instance, if the offspring, well, all offspring are going to come out what? All red. Okay?
Like you.
Like this. All right. So, all offspring are going to come out red. But in the instance that the offspring has the genotype, it already has the phenotype red. In the instance that the genotype is dominant R, this equals everyone with me?
Yeah.
This equals complete dominance.
Ooh.
That's me.
Oh, okay.
Exactly.
Okay? Stay with me. Alrighty? Now, we're going to go through another possibility. We still have that rose with the phenotype that is red.
Wait, this is another one?
This is another instance, yes.
Oh.
I'm sorry.
This rose's genotype is still dominant R. But now it mixes with a rose that has a phenotype of white.
Ooh, white roses? You make it blue?
So I'm going to do white. Do white. Just draw it in pencil.
Okay.
So therefore, what is the genotype of that rose? Talk over with your partner really quickly and tell them what's the genotype of that rose.
Double R.
Double
excessive R.
All right, raise your hand and tell me what's the genotype. Jenny.
Double recessive.
Recessive.
Yes.
Okay.
Do we have to say double?
No, I want you to say recessive. All right. So what's the possibility of the other rose's genotype, the last rose's, the offspring rose's genotype?
It could be
There's no B
It's
up
gonna be
here.
dominant.
It can either be
dominant and recessive.
It could either be double dominant R or double.
It
No,
could
it's gonna
never
be
be double R dominant or never double R recessive.
It's dominant.
Don't write this down.
What
But
the
just
heck?
to show you what we have here. We have one parent that looks like this, and we have one parent that looks like this. They're all going to be,
in the middle. The same.
Chappie, I'm explaining this to you.
I know, I'm trying to get a marker so I can draw my
They're all going to look like this,
I said that.
right? Dominant recessive. So, Stay with me because we really have to get all of this done. So our offspring is going to be dominant recessive. Now, this would explain then why
It could be
we end up with
pink.
a pink rose and not a red one or a fully white one. Will this couple ever make a white rose?
No.
No.
Sorry.
This is called,
Unless they got
did the dominant characteristic take over?
A little bit.
No.
No, it didn't take over fully.
Yeah.
Only some. So this is called incomplete dominance. Stay with me. We don't have time to do the extra talking, guys. This is called incomplete dominance.
Oh.
Okay?
Yeah.
Any questions?
That was loud. She didn't even hear.
All right, our last example. We still have that dominant red rose. Dominant. I need for y'all to get serious and grow up real fast. No, we can't take a little break. We took a break already, 80s baby. We don't got time for breaks. We about our business. What's the genotype for this? Dominant. Now we're going to have the same situation where we have the white rose. What's the genotype for the white rose?
Recessive.
What's the phenotype for the white rose?
No.
White. Thank you, Brandon.
Oh, description.
Who said it? Troy?
No, right.
Oh, okay. I said thank you, Brandon. All right. So in this instance, we will still get a rose, obviously. A rose is still a rose. That's what Aretha Franklin said.
I like she
A rose. No, ma'am, that's Luther Vandross. All right. What is... That's Luther Vandross. I'm talking about something else. What is the genotype of the offspring?
Yellow.
Ma'am, the genotype.
Oh, dominant recessive.
Raise your hand so that we hear it on camera the right way. Jake is scary.
Dominant recessive.
Dominant recessive.
Oh, you were
So,
Hey, website.
with this rose, this particular rose, it may not be a fully red rose. It's not going to go pink rose. Have you ever seen a white rose that has streaks
No.
of red
Yes.
around the petals, on the edges? If you haven't, they do exist. What this is called, notice they're both existing together. They both show up together. What's the root word for together?
Oh my God.
Like when you work together, you live together.
Coexist.
Co. So we have co what?
Cohabitate.
Co-dominant.
Miss Wiggins, that's I think.
Co-dominance.
Wow. You're so supportive.
And so this means the offspring will show both alleles.
Oh, Miss Wiggins. Sorry.
Yes.
Is that when like when a mother has a baby, then like if her dad has like red hair and her mom has like blonde hair or something, then it's
Like I have co-dominance. My hair is brown, but I have streaks of blonde and red in it from my dad. All right. Any questions for this?
Not anymore, Miss Wiggins.
All right. This whole instance of you taking one trait from your parent and another trait from your parent and then determining what your trait is, just like your chromosomes, they mix in that, what's the word I'm looking for? Crossing over, they mix. This whole thing, the separation of, I'm not just taking just my mom's, I'm not just taking just my dad's. Although, maybe your mom has light brown hair, or maybe your mom has blonde hair, or maybe your mom has red hair, but your dad has black hair or dark brown hair, and you have your dad's. Yes, you may have inherited exactly what your dad had, but you still have the trait of your mom. You may just be this one or this one because you carry that recessive trait. Does that make sense? So it's been a separation of the two. It's been separated out. 1 second. So therefore, this whole process is called, and I'm just going to write it right here because I don't have space right there, but you write it right on that line. This is called the law of, what's that term that's been used, that kind of been frowned upon for separating?
Segregation.
Segregation. This is called the law of segregation. Good job, guys.
Well, how come my brother's eyes be gray sometimes and mine don't?
Again, your brother had a totally different Punnett square. He may have ended up with one of the other possibilities. Your parents may carry that recessive trait. All right, so this is called the law of segregation. Talk to your partner really quickly and talk about what this law may mean in accordance to what we just wrote. Go ahead. 10, 9, 8, 3.
Oh, you scared him. You scared him.
1. Stop. All right, free. Right here. All right. All right, so tell me, Troy, what did you guys talk about?
I said what we talked about was that the law of segregation is that
Come on, Troy.
we talking about like that you can get different outlines like red, one red, and then
So they do what, though?
Huh?
They do what? What do the genes do?
Split off.
Separate, split up. So here, because they separate, meaning you get some from your mom and some from your dad, but then they split up to determine you. So here, it equals the gene pairs. Those gene pairs are called what again? Started with an A. Alleles.
Allows.
Stop this extra talking, 80s baby. What does word segregate mean?
Separate.
Separate. So they separate. Giving one from who? From each parent. To the who? To the offspring. And then you just want to put a note to see the Punnett square so that it reminds you of what we're talking about. We're going to write 2 small things and then we're going to be done with the notes.
This is small too.
You have space right there at the bottom in that bottom section. Yep, we're going to write them. I'm going to write them right here. I'm going to write one on this side. I'm going to write one on this side. Sometimes in an instance where we have the first, quiet guys, we got to finish this up. In the first instance where we just had dominant recessive, that means we're only using one type of gene. So I'm going to give you the definition and we're going to determine what that may mean. So this is a cross. How many S's is in cross? Not 3. 2. A cross between 2, give you a moment to write, organisms involving one trait. The key word is one. So, for example, we may just be looking at shape. So that would be an example if we were just looking at round or
Square.
not round. If we're talking about P's right now. Okay, so what's the root word for one?
Oh no.
No, it's another one. Starts with an M.
Mono.
Mono. In this instance, this would be monohybrid. Hybrid is a mixture. This is a B. Monohybrid. Mono, meaning we're only looking at one trait. But if we think about something like your hair is not just straight or curly. Sometimes it's wavy, right? So therefore, we have another instance. If the bell rings, do not pack up because I have 30 seconds to give you this. We have one instance where it is still a cross between two organisms but now it's involving how many? Two. That's the key word. Traits. Don't yell out, please. And when I'm going to put two different traits, it should say. Two different traits. So, for example, we may now be looking at shape and color. So this is when you end up with something that may look like this. Dominant R, recessive R, dominant G, recessive G. Or, and when you cross it, you can cross it with another dominant R, recessive R, dominant G, recessive G.
So if my friend can't see, I thought you just said that.
I did. Those two parents can still have the same, they can look the same when we're going to look at the possibilities. Any questions about this?
Yes, because.
What's the word? Oh, I'm sorry. What's the root word for two?
Bye.
Another one, when you're in half, like if you're cutting something in half and making two.
Split.
Pop, pop.
Dihybrid, like dissecting. Now, really quickly, because we're, actually, what time do we leave out here? Oh, no, wait, we got time, never mind. I'm thinking that we're on a short schedule today. We're not. All right, so what I want you to do is I want you to go ahead and take out your paper that says more Punnett squares. Because we're going to practice that really quickly so that you have enough to do, actually not more Punnett squares, flip it over to the back. My apologies. Flip over to the back really quickly. And while you're flipping over to the back, I want you to discuss this information at the bottom about the dihybrid and the monohybrid with your table. And then flip over to the back so that we can do some examples.
Let's get lit.
See how much we can cover when we are not playing?
Exactly.
All right. So looking at the law of segregation, we're going to use this law of segregation to illustrate or demonstrate how it is possible for a child to be born with sickle cell anemia when neither parent has sickle cell anemia. All right? Pay attention, Drika.
I was letting you see my paper.
We're going to use the letter S for sickle cell anemia. But in using that, understand that actually we'll use an A so that you can see it better in here, because S is obviously you don't know which one is capital, which one is lowercase. So if a child comes out with sickle cell anemia, but neither parent has it, that must mean that the sickle cell anemia trait must be what? Say it louder. Recessive. Let's jot that information down. Let's underline this. Let's say how it is possible for a child to be born with sickle cell anemia when neither parent has sickle cell anemia. So they must be what?
Recessive.
They must be recessive, or not they, the trait. the trait must be recessive, which means that the parents must be what?
Dominant.
No, the parents must be what? Do they have the disease?
Oh, they're carriers.
They must be carriers, which means the parents are carriers.
Oh man.
So therefore, like I said, we're going to use the letter A for sickle cell anemia. Now, what do we have to do first?
Draw a box.
Draw a Punnett square. Here we'll just put the mom or the dad. The mom, it doesn't really matter. One of the parents. But what is the gene pair or the genotype of the mom? Medicine. Yes.
You know how like people they get the baby later on in life and they had it in their blood for a long time? Does that mean they like the trait was
Let me check on that. Not really 100% sure to give you a 100% answer. So let me check on that. All right. I'll think about it. So what is the genotype of the mom? Let's say we're putting the mom up here.
Dominant R.
We're using A's.
Dominant A, dominant recessive A.
Dominant A, recessive A. Because the parent must be a carrier. So she carries it, but she doesn't have it. Which means sickle cell must be recessive. What's the dad?
A. Recessive.
Dominant A, recessive A. It says neither parent has it, Drika.
Oh.
So therefore, what's the possibility of this child? Dominant A. Will this child have it? No. What's the possibility of this child?
50-50 chance.
Dominant A, recessive A. Will this child have it?
No.
Drika, listen to my question. You're yelling out something I'm not asking a question to. Will this child have sickle cell?
Yes.
No, but this child will be a what? Carrier. What is this? The genotype of this child? The possibility.
Dominant A.
All right. Will this child have it?
Yes.
This one. Pay attention. Carrier. What is the? And do not yell out, guys. Answer the question that I am asking. You may get it off the top of your head or off the bat, but someone else may not. What is the genotype of this child? Recessive A. Recessive A. Will this child have it?
Yes.
Yes, this child will have it. So using the law of segregation, which is this Punnett square, we just illustrated how it's possible for a child to be born with sickle cell anemia, even if they never have it. So what's the chance of this couple having a child with sickle cell anemia? 25%. And this represents my cousin and his wife and their baby that was sickle cell anemia, but neither one of them had it. Any questions about this?
No.
All right, then let's move on to our second example because this is where it gets a little bit tough.
That was funny.
All righty. Dihybrid example. What is dihybrid again? Two what? Two what kind of traits? Two what kind of traits?
Different.
Two different traits being expressed. So let's take a look at this example. Alrighty. So it says, in guinea pigs, rough coat is dominant over a smooth coat. So rough coat is dominant R, smooth coat is recessive R. In black fur, dominant B, is dominant over white fur. One parent has a genotype, dominant R, dominant B, recessive B. What is the phenotype of this parent? Talk it over with your table.
Is rough coat.
Wait, rough coat,
All right, Hernandez. What's the phenotype of this parent? Parent one. Rough coat.
rough coat and black and white.
Thank you, Hernandez.
You're welcome.
Rough coat and black fur.
Is white too even?
It's not white, that's recessive. It's a carrier of white, but it has that dominant B. Remember, dominant will always be over recessive. So because it looks like this, that's the rough coat, dominant B, recessive B. It has that dominant B. That's the black fur. Parent 2 has a genotype of dominant B, recessive B. I'm sorry, dominant R, recessive R. Dominant B, recessive B. What does parent 2 look like? Fantasia. What is this one? What does parent 2 look like, Fantasia? Rough coat, black fur, still. Too much extra talking right here. So now we need to show a cross, and this is where you really have to pay attention. We need to show a cross between the 2 parents. Give the genotypes and the phenotypes. So we're going to put, just so that we see what we're doing, we're going to put parent 1, well, I'll put it up here. Parent 1 here, going that way, and parent 2 will go down. So what's parent 1's genotype?
Dominant R, dominant B, recessive B.
What's parent 2? Dominant R, recessive R, dominant B, recessive B. Now we have to do a cross between each of them. So we have to combine everything. But when we do this, what we need to actually do, I didn't do this correctly, I'm thinking about it.
Uh-oh. You made a mistake.
No, you did.
Try to be quiet. This is dominant, let me erase it and start over.
We can't erase.
It doesn't matter, you'll be fine. You can cross out. So this will be dominant R.
Oh.
It goes like that. And I'm not going to make you do this part for homework because I want to explain this part a little bit more. So
we don't have
I want you do have homework for one part of it. I know, because what I'm doing, what we need to do is, these are all of the possibilities of the first parent. So you have to put that down.
Wait, what do you mean, like,
Let me stop here because I want to go in. That's what I knew this was going to happen. I want to go in more detail. So we're not going to do this one. So what you actually need to do for homework, no, is this.
That packet?
This one. Listen up. You do not need to complete the one that says genetics homework. So on your way out, if you would go ahead and put that back in this tray so that you don't get confused. But you do need to complete the one that says more Punnett Square, and I'll update the website to say that. The website will also have a copy of the test for you to do your test corrections, which are due now on Thursday.